Welcome to MegaDonkey tutorial prototype number 1. This is an experiment using YouTube for a little bit of documentation on a new microcontroller product that we are now releasing. MegaDonkey is an Atmel Mega 128 and also Mega 2561 touchscreen LCD controller. It's a general purpose controller. It's programmed in C. And unfortunately, I don't have any live video of the product. So we have a slideshow for now, but I will be able to show some real-time graphics that are actually shipped from MegaDonkey over to the PC. Here we can see a board of the reverse, or a view of the reverse side of the board, and there's the microcontroller. We have a 40-pin expansion connector. We also have 2 serial ports, RS-232 level serial ports, along with a header that contains jumpers to allow jumpering RTS and CTS, or not using those features and having those pins available for general purpose I/O. We have a speaker, voltage regulator, reset button, some limited prototype area, and also a programming header for in-circuit or ISP programming. We have an I2C header for connecting to I2C peripherals, and also a JTAG header. Programming can be accomplished using a bootloader, so you don't need a programmer. You just use a serial port connected to your PC. The first thing I want to show you is the variable editor, and this is an example application running on the MegaDonkey. And what you're looking at is a facsimile, or really an exact duplication of what is on the LCD screen. In fact, not only can I press the touchscreen on the LCD, but I can also use my Windows cursor to actuate the functions. And for example, this variable editor has 2 variables defined. In this case, I have 2 hobby RC servos, each with values from 0 to 1,000, describing their range. And I can independently control these variables, and I can also read and write them from EEPROM, which would be very helpful in a program with many parameters. And also we have a group button, but I only have 1 group of variables defined, and this allows us to quickly navigate from group to group of variables. Makes it very convenient, especially if you have an application with 50 or more variables that you might be wanting to tweak. You can jump from group to group. Let's take a look at the code that backs this up, just to see how simple it is to use the variable editor and integrate that into your applications. Here's our example application, starting with a couple of header defines, and this is in the program. The MegaDonkey is programmed in C, and so here we are declaring some references to header files to give us our function prototypes. Anyway, standard to every MegaDonkey program is the md.h header, and also fairly standard would be calling in the LCD library and the standard I/O library for support of formatted printing using the standard printf that C provides. Also in this application, since we're using hobby servos, we're including that module, the variable editor, and we're including the remote display terminal MD term. We've got 8 servo values defined in an array here. Then next what we have is the declaration for the variable editor, and this is really fairly simple. We define a function and we give it our own name. In this case I chose servovars. And we define groups, and 1 group is required, so I have a group called servos. Really doesn't, in this case, doesn't really matter that it's descriptive since we only have 2 variables. And then our 2 variables follow, and they are servo1 and servo2, which are declared in an array. They could be simple variables. In this case, veint says that we're going to be adjusting an integer value, and it can be 8 bits, 16, or 32. Also, we provide a legal range, and this helps scale our slider control that we saw earlier as we were able to move back and forth and adjust the sliders. And let me go back to that. So here we're back here, and we can see I can vary from 0 all the way up to 1,000, or 999. We can actually hit the We can do individual tuning here, or we can also just click on the slider and set the values. This is really handy for making adjustments to a microcontroller based system, or for example a robot. So next we need to see how this code is actually referenced, and so now we will scroll down and see our main program. For MegaDonkey, we're required to call MD init. That takes care of basic screen initialization, and in this case we're sending everything to a remote terminal, or our MegaDonkey terminal, so it requires one other function call and specification of what serial port, in this case serial port 0. For our servos, we're initializing an 8-channel servo controller, which is built into the Donkey's firmware. And we are also setting up a table of neutral values, 500 being center for our servos. And next comes our initialization for our variable editor. And this is done by calling VEinit, and that the name of our function that we defined. And I have just a temporary thing I'm doing here, which is a bit of a kludge for our multi-channel controller, and that will go away in the future. Next, we have the actual invocation of the variable editor, and we can run that in a very tight loop. We have a function called VEupdate, and when it's called, it quickly looks to see if there's any input, any changes, does the changes, redraws whatever part of the screen it needs to, but then it exits. And the reason we do that is it allows us to execute other code while we're running the variable editor. So in this case, the only thing I'm doing besides running that little loop there, or within that loop rather, is I'm taking my values. In fact, I'm updating all 8 defined. We were only editing 2, but I'm sending all of those to the servo controller, and that's a function called servo pause, and that is given a channel number and a servo number. This program, or this loop, executes until the user presses the little close box on the variable editor, in which case program control then follows down. Let's see if we can get this to scroll up here. And I'm stuck. I have a fixed window. I can't scroll any further. Anyway, after the loop exits, in this case we called servo stop, and that shuts down the RC servos, and then I have just an end of program. So really we're looking at about 10 lines of code for all that functionality, which is pretty neat and easy to do. And this concludes our little demo. So I'll close that.